Hello everyone. Welcome back to some more discussion of how to set up signaling using JMRI and specifically the SE74 from Digitrax. I was specifically asked to talk a little bit about a more complex situation where we have two crossovers back to back with the points connecting here at the bottom. Let's talk just a little bit about my nomenclature. I call this mainline 1, mainline 2. And I tend to then use the numbers 101, 102, 103 for the blocks. And each turnout has its own block, which in this case, just so that I understand that it's a turnout, I use four numbers, so I'll use 1011 and 1012 for those. 2's on the bottom, again 201, block 2021 for turnout 21, so forth. And I start my turnout numbering 11, 12, 13, 14, whatever. And on the second main line, turnout 21, 22, etc. It just kind of keeps things a little more simple. So at any rate, the problem is how do we want to set up signaling for these various turnouts? If you've watched the other videos, then you know how to set up, for example, the signaling for a single crossover here. And that was explained before. We won't do that again. I will put those signals in here and we'll talk a little bit about them. But the logic behind them, I'm not going to dwell on too much, although we will cover a little bit of the logic because there's certain things that we want to make sure that everybody understands why we're doing a particular thing. So also the other concept that we would like to do is to use the minimum number of signals that we can do rather than putting a whole bunch of signals along here that clutter up and really start to become difficult to not only set up but also to read if you're the engineer or running your trains on this layout. Also, I'd like to point out that I consider or assume that the two turnouts making one crossover operate together and not independently, so that if we change this turnout, it also changes turnout 11, so that the crossover is complete. We assume that you don't turn one turnout without the other one. You may find a situation where that's necessary. In most cases, I don't think so. So both of these turnouts are set up to operate together and not independently, and that will affect what kind of signals we put in here. For example, if you're familiar with the terminology from before, we would have an A1, A2 signal here. We would not need a C signal coming this way because we assume that if you pass this turnout with an A1, A2 signal, that it was clear all the way through. We will have a B signal here and a B signal over here. The problem that we would like to avoid in this case is to not have a whole bunch of signals in a row up here. Now, some people might say, well, this particular block should be split and part of it go with block 1011 and the other part with block 1012. Okay, I could go along with that. However, the way I set it up, there is a block between these two turnouts. It may or may not become an issue, but the point that we're going to have here, the main concern is how to deal with the signals on this upper turnout, or upper main line, because we would like not to have to put signals here, 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 and here to accomplish our mission. And we'll talk about that in just a minute as we look at how we place the signals. Okay, now I have added various signals at the points where I think they should be I've labeled them appropriately. For example, here, this is turnout number 11, A1 and A2, the top one being A1, the bottom one being A2. If you need to go back and look at some of the previous videos where I explain why this terminology is used, it might help you to understand what we're doing here. If you remember all of that, fine. I'm going to run through a couple of things with you here about why we're setting this up this way. Again, this would be turnout 21, the B signal, and you notice that nowhere on here do we have a C signal. So we're not using those. We have 2, 4, 6, 8, 10 signal heads that we're going to set up to operate our layout. Okay, in this situation you can see that I have placed the signals and I've made all of the normal logic that we would encounter with a signal element, except we do not have any C signal heads placed on here, as I explained before, because we'll assume that if we are making the crossover, we'll assume that these lights up here, if this is green for the turnout and this is green for the turnout, that we don't need a C to indicate that this turnout is set correctly, because this light will govern passing here all the way down until it gets onto the second main line. So in this case, we have, for this turnout complex right here, signal element, if you want to, this is A1 and A2 for turnout 21, and this is B for turnout 21. Likewise, we have A1 and A2 for turnout 22 here, and we have 22B up there. We've also placed the A1 and A2 signals for turnout 11 and turnout 12. Notice that in this case there is no B for the main line against the turnout or against this turnout. And again, we don't have a C because we're assuming that this signal and this signal head will control the flow of traffic through the turnout, through the crossover. All right, so at this point then, we have all of the normal operational heads set up as they should be, so that as we turn these turnovers, the straight through goes red and the turnout for the crossover is green. Likewise here, this goes green if on the bottom for the turnout going through the crossover. Same with the signal heads for turnout 12. So these are all working as we would expect them to, as we have demonstrated in previous videos how to set them up. We also have connected all of the block detection, so that you can see in our block detection, in our sensors table down here, we have all of the blocks listed, and if we make any one of them active, like 101, you see that block 101 over here is now red, and likewise we can make any of the blocks be active by just clicking on the sensor and making it do what it, change to active, and then it will do the appropriate thing. So for example, right now the way this signal here is set, we have a green saying that there is no train in either block 1011 or block 102 or block 1012, because we've said we don't want them. If there's a train in any of those, we want to hold the next train back here. So if we make any one of those blocks active, that goes to red. So just to check on that, we can right click on the signal head, go to Edit Logic, and I'll bring it down so that we can see it. You'll see here that we are protecting all of these blocks. We're protecting block 1011, block 102, block 1012, and additionally block 103. So no train can go past this signal if any of these blocks are occupied. For example, if I go here and make block 103 active, you'll see then that this light goes to red because it's monitoring. If there's a train clear over there, we want to hold all the trains here. We don't want them to get into the signaling complex at all. So now that we've reviewed this again is the controlling turnout. That's all that has been done in the setup for the signal logic so far. And if I put this block 103 back to inactive, then of course the green light is showing correctly. We do have a problem here, and this is the one that one of our viewers asked me to look at for his own particular situation, how to set it up. And it gives us a chance to look at something called Logix. And I'll go through how we're going to do that. Here's the problem. If, for example, this turnout is set for the crossover over here, shouldn't this green light go to red? Because the train cannot go straight through there. We do not have any other signal to stop the train from going through a thrown turnout. And that becomes a real problem for us because we have to have a way to make that light go red to stop the traffic. Likewise, if we do it the other direction, we need to make this signal go red because you can't allow a train to go past this point going this way. And with our normal setup, the way we have set up everything from previous videos, there's nothing that we could do that would make that correct. We need to use something called Logix. And what this is a very, very hardy system of question and answers to set up something on your railroad the way we want it to be. So basically what we want to do is to have a method so that if this turnout down here, 1012, or turnout 12, is set for the crossover like this, we want to be able to make that light, that signal, A1 for turnout 11, we need to make that go red. So that's what we're going to work on right now. Now, in order to do that, we need some kind of a sensor that when we go into the logic for turnout 11, we need to have one more sensor that would cause it to go red. Right now, if any of these blocks are occupied, this light goes red. If the turnout is closed, if the turnout is thrown, that light goes red, obviously, because you can't go straight through. But what do we do if this one is thrown? We need to make this go red. So what we need is a sensor that we can add here so that if that sensor is active, then that light would go red. And that's what we're going to work on now. So what we need is a sensor titled Turnout 12 Closed. All right, so I'm going to come down and I've got a bunch of sensors down here that are already set up, internal sensors. We've already set up all of the sensors for the blocks involved in this. Now we're going to name a sensor, and we're going to call, actually we're going to get two of them. I want a sensor to say if this turnout is thrown, turnout 11 is thrown, it becomes active. And I want one that says if turnout 12 is thrown, it becomes active. So we're going to add two turnouts down here. Well, they're already installed, as you can see. I've got several internal sensors already set up there. But what we want to do is specifically name it. So I'm going to put a username in internal sensor 11, and we're going to call that turnout 11 thrown. Now, if I could type, it would help. Okay, so that turnout 11 thrown is the name of a sensor. Isn't going to do anything yet because we haven't told it how to work. There's no actual sensor like block detection or anything hooked up to that. So for right now, it's just a named sensor that we can use. And I'm going to also name one turnout 12 thrown. Turnout 12, let's put a space there. Turnout 12 thrown. So we now have two sensors with specific names. You notice that if we make them active, nothing is particularly happening. Nothing is happening. Now here's how we're going to use them. We're going to go up here to this A1 head, and we're going to edit it. And what we're going to add to this is in our list of protect sensors, we're going to add the turnout 12 thrown sensor. That's the one that we just defined down here. So I'm going to add, drop down box. I got a bunch of other sensors in here. They don't mean anything. But up here, you'll see that we have turnout 11 thrown and 12 thrown. We want 12 thrown so that if sensor 12 thrown is active, then it will cause that light to be red. So we'll click apply, we'll click close, and nothing has happened yet. Even though that turnout is thrown, we haven't told sensor 12 any way of knowing that. We have to get to that point. But let me just make it active and see what happens up here. Notice that that A1 light for turnout 11 now goes to red. If I make it inactive again, then the turnout goes back to green. So if I click this turnout to go to the crossover position, nothing happens to the A1 light over here because we haven't yet shown the sensor 12 thrown sensor how to interpret that turnout, and we'll do that. But everything is connected. All we have to do is make the sensor respond to the position of the turnout. And that's what we're going to do next. And that's where we get into a whole new area of JMRI, which we previously haven't discussed, but it's very powerful and very useful. And that is in the area of logics. Now, what I'm going to do is click Tools, Tables, and we come over here to Logix. Now this is another whole table. When we open that table, we get this display right here. And as you can see, there's nothing in there. We haven't put any Logix situation in there. But what we're going to do now is tell JMRI how to make this turnout 12 thrown sensor active. And the way we do that is we add Logix. And we start by coming down to the bottom and clicking on add, and we get this add a Logix. And we're going to give this, first of all, we click on the automatically generate system name. We don't want to have to keep track of how the system deals with these things. But in order to create it and use it, we ought to give it a name. We're going to call this logic the turnout 12 status. And we'll create a logic system based on that. So once we've typed in the name, it's automatically going to generate a system name. We click on create. We're going to get some new boxes. And this is what we work with to make the Logix do what we want it to do. In this case, Bring it down a little bit, size it so you can see it. I try to keep it so we can read all the terminology on here, so it's sometimes the stuff is a little bit out of the camera view. But this is how we set up a Logix, and our Logix here is turnout 12 status. In other words, we're going to make that turnout 12 sensor down at the bottom either active or inactive. And we do that by starting off, we have to create a new conditional. Now, some of you may recall from your high school Logix class, if you ever got that far in math, what we're creating is an if-then situation. In other words, if this is true, then do this. And that's what all of these are about. There's two parts to this new window that has opened up. One part is at the top, and that's going to be if this variable, and we'll add a state variable. If that variable is true, then do this action down here at the bottom. And that's what we're going to set up. So to start off with, we're going to give this particular action a name, and that is if turnout 12 is thrown. And the way that we're going to determine that is, first of all, we'll come in here and we'll add a state variable. All right, well, that's going to give us a new box. Got lots of boxes to fill in. This box is the variable that we want to examine. And the variable we want to examine is the turnout. So we'll click on turnout. That then says we have to come up with a name, which username, which turnout do you want to examine? We want to examine turnout 12. And we will then update that. And what we get now is a statement up here that says turnout TO12, that's the name that we've given it, state, is turnout thrown. And if that becomes true, if the state of that is true, in other words, if turnout 12 is thrown, then what do we want to have happen? So that's the if statement up there. Now we're going to add an action. So down at the bottom we say add action. Oh, another box we have to fill in. In this case, what we want to do is set a sensor. And that sensor that we want to set is turnout 12 thrown. We want to set that to active. So right here we'll put in turnout 12 thrown. That is the sensor. That's the name of the sensor that we have in our list. They give us a box over here. I can't get everything on at the same time, but there's the name of the sensor that we want to set active. Okay, so what do we do? Well, the action that we want to take is right here. We want to set the sensor, set sensor active on change to true. So that whole statement is what's going to take place. If the turnout is thrown, then this is the action that will take place. So we'll click update, and now we see the whole if-then statement. If turnout 12 state is turnout thrown, then when it changes to true, set the sensor turnout 12 thrown to active. And that's how we tell the sensor to go to the active state. So we come down here at the bottom, there's an update button. We click update. And now we have this whole conditional set up to turn that sensor to active. If we throw this turnout, that will go to active. And because it went to active, this A1 light over here for turnout 11 has gone red. And that's what we wanted to have accomplished. That's how we get that turnout, or that sensor, to the active state. So by turning this turnout to thrown, we have accomplished setting the sensor to active. By setting that to active, we have made this light go red because in our list of things to monitor, turnout 12 thrown sensor is one of the sensors that we are protecting. Now the problem comes that we set that active, okay, but we didn't tell it when to go inactive. So if I turn this turnout back to the straight position, notice this light is still red. Why? Because that sensor is still active. You have to tell it to do everything. It is not automatic. So we have to go back to that conditional, or to that Logix system that we set up, and we have to add a statement telling it when to go back to the inactive state. Otherwise, you're never going to allow a train to go past this signal down here. You're never going to get it to go back to inactive. And we want turning this back to the closed or straight through position. We want that to make the sensor go inactive again, which would then allow this A1 light to go back to green. So in order to add that instruction, we have to come down and open up our Logix again. And here is the logic system that we were working with that caused it to the signal to go red in the first place. We're going to select that turnout 12 status, and we're going to edit it because we have to add another conditional. We've got this conditional. We already know what that is. We could go in and look at it by clicking edit, and you'll see all of the stuff we put in there before. Well, we don't want to mess with that. We've got that set. So now we're going to add a new conditional. So we come down and we say new conditional, and we get this box just like we had it before. Well, what conditional is this? What are we actually working on? And I'll just move these boxes around a little bit so we can go back. What we're working on now is if this turnout is then set to straight. So what I'm going to call this one is turnout 12 closed. So that will be the name of this conditional that we're going to now give instructions so that if the turnout goes to closed, we can set that sensor back to inactive so that it will control our A1 signal the way we want it to. So what are the conditions? Again, add a state variable, and that variable is turnout number 12. So we put in turnout 12, spelling counts, capitalization counts, and spaces count. So when I named that turnout, I called it turnout capital T, capital O, space 1, 2. If you don't put that in there, it won't work right. So you have to be very careful about using the proper names that you have set up. In this case, what we want to do is if the turnout 12 goes to state closed, okay, that's our if statement. If turnout 12 goes to closed, we'll update it. That's the if part. So now we've got turnout 12 state is turnout closed. So if turnout 12 goes to turnout closed, what action do we want to take? Well, the action we want is to set that sensor, which is turnout 12 thrown sensor, back to inactive, saying no, it's not thrown. So here's the sensor. We have to spell it again correctly. So it's turnout space 12 thrown with a capital T. So turnout 12 sensor, that's the one we want to set. And what action do we want to take? Well, set sensor. And what do we want to set it to? Okay, if the if statement is true, in other words, if the turnout goes to 12, turnout 12 goes to closed, we want to set this sensor to inactive so that it will allow that signal head light to be back to green. So now we have set that up. Sensor turnout 12 thrown, set it to inactive. Okay, we click update. And now we have another whole set of instructions here. If turnout 12 state is turnout closed, then set this sensor to inactive. That's what we have set up. So down at the bottom, we'll update it. And now in this whole logic system, we've got two conditionals. One, if that turnout goes to thrown, one, if it goes to closed. And we've dealt with both of those situations. So we've told this sensor down here, the turnout 12 thrown sensor, when to go active and when to go inactive. So we're all done with this. We can go done. And now, as we operate this turnout, it goes to red over here to A1 because that turnout is closed. That sensor is active. When we go back to the closed position, that sensor is now told to go inactive, and that allows the green light on A1 to allow the trains to go through. So we have now set that up so that the A1 light will hold all traffic at this point until everything is clear. Not only the blocks vacant, but also that turnout 12 is set for straight through. As it is now, we get a green light in both directions. This light is monitoring the position of the turnout directly, just like we've always done. But this one had to have some extra work because you can't monitor two turnouts with one light. So that completes our setup for this direction. But now, what happens if this turnout is set for the crossover? Notice that the green light at A1 is not stopping the traffic, and you've got traffic approaching a thrown turnout. So we want to do exactly the same thing that we did before to set this one up so that if this turnout 11 is set for the crossover, that no traffic will go past this point. Well, we've already set up the sensor down here, but we haven't done anything to tell it when to go active or inactive. So the first thing we're going to do is we're going to put that sensor into the logic in the setup for the turnout 12A1. And notice that we've got down here space for that turnout number 11 thrown sensor. And we'll just go up here and pick that up. I don't know if you can see it, but it's up there. Turnout 11 thrown goes in here. And now, if we apply and close, then if we make sensor 11 thrown active, this light down here goes red. A1 light is red as we go active or inactive. But we haven't done anything to tell that sensor when to go. So even though we're changing the turnout down here, the light remains green because nothing is telling the sensor to go active. So now we have to build that logics as well, just like we did when we were talking about this turnout being turned to the crossover. So we'll come down and we have to open up our logic table again. And now we're going to add a whole new set of logics. So we're going to add a logic statement. And this one is going to be not turnout 12 status, but turnout 11 status. So I'll make that turnout 11 status and I'll create the logics. So far there's nothing in there. This is where we add our various conditions, the if-then statements. So we're going to add a new conditional. That brings up a new window. I have to keep moving these around to try to get them where we can see them. They come up all over the screen, and if I get the camera any further away, you can't see them. Okay, so now we're going to add a new conditional. So the first thing we have to do is say, what's the if statement? Well, the if is, if turnout 11 is thrown. So here we go. What variable type? We drop the box down and we get turnouts right away. So if turnout, and this is where we have to type correctly again, turnout space 11, oops, that's what I say, it won't work and you'll have to go back and figure out why. If turnout 11 is thrown, well, that's what we want. So that's the if statement, and we'll update it, and it goes up here. It says, if turnout 11 is state thrown, then what do we want to have happen? Well, in this case, we want to set sensor turnout 11 thrown. And remember, spelling counts, so you have to get it correct with all the spaces in it. Turnout 11 thrown, and what do we want to have happen? We want to set the sensor to active. Okay, we update. Now we have our if then. If the turnout is state thrown, then set the sensor turnout 11 thrown to active. Okay. So now we can come down to the bottom and update that Logix. And again, we've got that part of it all set up. But if we go back up here and we throw turnout 11, it correctly sets the A1 signal at turnout 12 to red. But because we didn't tell how to turn off that sensor, didn't make it inactive, if we set that back to straight, we don't get a change because the sensor is still active down here. So it works this way. It'll make it go active, but it doesn't make it go inactive. So we go down to the Logix setup that we were working on. We've already put in what happens to make the sensor go to active. We now are going to add a new conditional to that Logix that we were working on. So we get this table again, this window, and this one we're going to say turn out 11 closed, and we make the if statement. We add a variable. The variable we're going to add is the turnout, and that's turnout 11 with all the spaces and capitals appropriate. But this time, the variable state that we want is closed. So if that turnout goes to closed, that's the if statement. If turnout 11 is closed, then what are we going to do? And we add the action. We want to set the sensor, and the sensor we want to set to inactive is the one that says turnout 11 thrown. Because it no longer is thrown, we're going to set the sensor to inactive. That's the then portion of the if then. If this is true, then do this. And that will then tell JMRI how to set the sensor back to inactive and allow that signal to go to green. So at this point, we now have, let's make sure that we've updated everything. We're done down here. Okay, now as we turn this turnout to the crossover position, we get the red light on the A1 signal at 12. And if we go back to the closed position, the A1 signal at turnout 12 goes back to green. So that we have completed the entire setup for both directions. If we operate this one, we get the red light on number 11 A1, and it goes back to green, and vice versa If we turn this one, then 12 shows red on the A1. So that completes the entire setup for our crossover, considering this portion of the mainline 1. And that was the most difficult part. Now there's another portion that needs to be considered here. And it's interesting that as I was setting up for this video and I was going to install some other Logix conditionals, I learned a few things myself about how JMRI works, and I'm going to show you what those are. But first, let me show you what the situation is that we need to fix. This up here is all complete. There's no leftover parts. If we have any active blocks, they will cause the appropriate signals, and if we have turnout change to the crossover, we get the appropriate signals. So all of that portion is quite complete. But we have a little bit of a situation down here that presents a problem, and I'd like to show you what it is. No matter which way we turn this turnout, it gives us a green light. So that right there is correct, because that green light is telling us we're cleared through. We don't have to expect any additional stopping points, and because we've got a clear route, no matter which way this turnout is set. But now let's suppose that we have it set like this for the straight through, but there's a train sitting in block 202 over here. So I'm going to make block 202 active. Now, here's the situation that we have. We've got two red lights on this signal, the A1 and the A2, because there's a train in here, and the A1 signal is red because that block is occupied. If we turn this turnout, of course, then we'll get a green light as appropriate. But when we go back to straight ahead, we're getting a double red, which means the train has to stop right there. Well, according to the simple logic of the signaling system that we're using, it would say that this signal right here should be yellow. Well, this is where I learned a couple of things, and I was not aware of it, and I've tried to find how it's explained in the documentation for JMRI, and I couldn't find it spelled out that way, but I discovered that it is in fact working this way. I was going to build a whole nother logic system to help set this up to yellow. I'm going to edit the logic for this light, which is the B. It's 21B. If you recall, this is signal 21, and that was 21B. What that logic needs to do is it needs to set this light yellow if these are both red over here, which means you can pass this light, but be prepared to stop at the next signal. Well, that's where this protect signal block comes in. And what we are going to put in here is both A1 and A2 for turnout number 22. So we'll put turnout 22 A1, and then we'll put turnout 22 A2. This I did not know would cause a yellow light for us over here. And this is where I found out that it's a much simpler way of doing than what I was going to do. So I'm going to click apply, and notice that we get a yellow light over here. I thought that if these were both red, that it wouldn't do that. Only if one or the other went red. So I thought we'd always get a yellow light. I misunderstood that. So I'm going to close that off. And now let's just test this out a little bit. If we make this turnout go to the crossover, the lower signal head turns green. Now there is a green path that the train can follow. So there's no reason to make this light signal yellow because you don't have to stop here. You have a clear path. If we go back to straight ahead, now because there's a train or a blockage on that piece of track, these are both red and this signal is yellow the way it should be. If we take away the active portion over here, which is block 202, we make it inactive, then this has a clear path again, all green. So this ability to set up that protect signal like that is something that was new to me, and I only found it because I was getting ready to try to do a different way of accomplishing the same mission. And there is another way to do it, but this is much easier. Okay, so we've got this one set up correctly so that if this one, this block over here is occupied and we have 2 red lights, we'll get a yellow one here. But how about over going this way now? We don't have that. So if I make this one inactive and I turn around and make block 201 active over here, now we've got 2 red lights up here, but this one is still green. So in order to fix that the same way we did with the other one, we'll right-click on the signal, edit the logic. I'll bring the box down where you can see it. And the logic says what we have to do is to protect these 2 signals. So we'll choose turnout 21 A1, turnout 21 A2, and we'll apply and close. And notice now this light over here is also telling you that you can pass that light, but you must be prepared to stop at the next signal because there's no clear path ahead. If we turn off the active status for this block over here, make it inactive, then that signal A1 goes to green because there's no, it's clear path ahead. And this one goes from yellow to green because now there's no need to stop at the next signal. So if we go back again and make 201 active, again, we're getting a yellow light saying be prepared to stop at the next signal. If we change this turnout for the crossover, now we do have a clear path for the train to go. So maybe you have a train sitting here waiting to come this way. You can't go past this light. Maybe that train is planning to go up there. Who knows? Whatever scenario you want to set up. But as long as this turnout is set for the main line, then this signal is telling you you have to stop before you get to that signal. And it's a much simpler way. Again, I'll just bring this edit box out so we can take a look at it. All we're saying is that signal is, this B signal is going to protect these 2 signals, turnout 21A1 and A2, those 2 signals. And if both of them are red, then 22B will be yellow, saying that you have to slow down and stop at the next signal. That was something I learned in doing this. You learn almost every time you work with it, but that is a much better way of accomplishing it than using all the logics. Now we have completely configured this entire turnout system where we have 2 crossovers and we've got all of the lights giving us all of the proper indications for block detection and for position of the turnouts. If you have questions, enter them in the remarks below and I'll try to get back to you with an answer. But this would be my way of setting up this double crossover scenario. There's probably other ideas about it, and there's many possibilities using the Logix system that is part of JMRI. And remember, that Logix system is a table called Logix, L-O-G-I-X. And once you open that, then you'll see we have two separate conditional systems that are set in this simple layout to handle the two crossovers that would provide a problem on the upper main line. Each has then two parts of it, and you can go back and review them by selecting to edit, and then you'll see both parts of each of those conditionals that we had set up. Again, hope this makes sense, and I'd love to hear any comments and questions if you have them. Have a great day.